friends after this, Brandon.
We can be friends, yes.
There's a stem line for party. Somebody is. I love the shirt. Thank you. Yeah. Where'd you come from?
Where'd I come from?
Yeah.
Oh, just the house I was staying at. Just a fun night last night, and I'm giving a talk today that I was having.
Oh man, I did not have to give any talks except for the beginning of the week, which I'm very happy about.
Oh, wait, this is his. I'm sorry.
Yes.
That's yours.
I got it. That's yours.
Yes,
yeah.
you just need to turn it right here. Just a little switch. Yep, should be good.
I got it now. Give me a second.
Thanks for agreeing to do this. Yeah.
All right. Let's get started. Okay, so this is gonna be a really, really good panel, everybody. We got some OGs on the panel. Let's give everybody a big shout out. Okay, so let's start with some context. We're here today because we all believe in this amazing technology called zk. And zk has been, at its core, very complicated, finding market fit, product market fit in the past few years, and I believe we found it, right? We found one, scalability, and two, privacy as the main benefits of zk in the blockchain context. So here we have two camps here, literally represented on both sides of me. So we got zk Sync and Polygon on the right-hand side, and we have Aleo and Aztec on the left side of me. So according to this privacy and scalability use case, the architecture design of the blockchain are also different, vastly different, right? So we got the zkVM camp, which is here to solve the privacy issues, and the zkEVM, right, solving scalability of the Ethereum problem. So we're really going to just dive right into those issues and really figure out the differences, the different perspectives. I'm going to just give a preface by saying I am a big zk fan. That's why I'm working in this space. But I'm going to take off that maxi hat and just be a skeptic for the day and really push everyone on the panel, why we're doing the things we're doing. So there's no right or wrong answers, but different perspectives. So with that, let's get started, shall we? Okay. So first of all, just a quick introduction in 30 seconds. The name, your title, and your project, please.
Okay. Alex, CEO of Rollups, co-inventor of zk Sync. zk Sync is a scaling protocol for Ethereum. It's the largest zk network today on Ethereum, with a mission to bring zero-knowledge proofs and basically bring the entire world on-chain with zero-knowledge proofs, because I believe that this is the only technology which can actually scale Web3 to the entire world while preserving the key values that we hold dear in the world of blockchains.
Hey everyone, I'm Brendan. I'm a co-founder at Polygon. I work on zk stuff. Jaime from our team pointed out that this is the only panel that he's seen that has the word versus in the title. And so I guess I'm really excited.
Let's make it a debate. I'll real quick, introduce myself as well. I'm the head of BD at Aleo. But just so you guys know, I'm going to ask the most hardcore questions to Alex over here. My boss is here just to be impartial. Don't worry about that. Go ahead, Alex.
Hey, everybody. I'm Alex. I'm the executive director of the Aleo Foundation. Just briefly, Aleo's building a new layer 1 blockchain with a zkVM based on zkC, with really the goal of, the focus being privacy, and the idea being taking, how the internet went from unencrypted to encrypted via the transition from HTTP to HTTPS. That's what Aleo aims to do with Web3. In addition to that, I run zPrize, which is a nonprofit initiative to help accelerate zk proving, and before all that, I was an investor at A16Z.
Hey everyone, I'm Zach. I am the CEO and co-founder of Aztec and co-inventor of Plonk. So Aztec is a privacy-preserving layer 2 for Ethereum. So our thesis is that privacy is really the missing link required for blockchain to hit the mainstream and reach into everyone's lives and not just cypherpunks. And that having rich composable privacy in a smart contract framework is what's required for us to really add jet fuel into this world computer that we're building.
All right. Okay, so first, simple question. Let's start with that. In your own words, what is the difference between using zk as a tech stack for privacy versus as a rollup? Let's start with Alex. Over here.
I actually don't think there is that much a difference. Like Alex just brought up a beautiful analogy of HTTP and HTTPS and how it upgraded the Web 2 and brought our lives online. If you think of HTTPS, it does not only provide privacy, confidentiality of your communication, it guaranteed the integrity of communication. You could finally talk, you can use any device, access your online bank, access your medical records, work accounts, and so on, and be sure that this communication is going to be protected and you're going to be talking to the right party. It doesn't matter who is in between, like all the routers, internet providers. You don't have to trust them. It's a trustless communication between any point on the internet to any other point. The zk is doing the exact same thing for the world of blockchains, for the Web 3. It provides, from a different angle, unlike HTTPS, which enabled integrity of communication, the zk enables the integrity of computation. Because the blockchain network, or like a network of many blockchains, is essentially a global distributed computer which performs distributed computations on a huge shared state. This state can be sharded, it can be different chains, but it's you can consider it just like the internet is probably one global computer with different systems, same with the world of blockchains. And to communicate trustlessly and seamlessly and without capital costs, you need this layer of integrity, and this is provided by zk. So I think we're just leaning into one or another property of this technology, but it really has these two facets.
Yeah, I think that's a nice way to put it. I think that you can think of rollups as zk rollups as being sort of a way to constrain the operator of a chain to only behave in a way that's valid. So you can take a chain that processes millions of transactions off of Ethereum, and you can prove and you can guarantee on Ethereum that all of those transactions are valid, and so you can scale by moving compute off of the main chain. I do think that it's important to emphasize that these systems are not mutually exclusive. We can have rollups that also provide privacy, and we can build private applications and smart contracts on zkEVMs as well. And so, I think that zk just opens up a huge design space for both privacy and scalability.
Any things to add on that?
Yeah, I think this is a perfect point too. I mean, since this panel is all about versus, I think this is I would share a different perspective. So I think I agree that rollups and HTTPS, I guess in cybersecurity, there's three concepts that are often cited: confidentiality, integrity, and availability or authenticity, depending on who you ask. And I think what we just heard about from rollups is the integrity of computation. And I actually am not a big fan of the term zk rollups because I think the zk snarks. The zk stands for zero knowledge, and the academic term means the verifier learns nothing about the statement being proven. But in most rollup designs, including those deployed today, by virtue of how the structure is set up, where a user submits a transaction to a prover, the prover kind of learns the content of that transaction to generate a proof that then technically the verifier on Ethereum it doesn't reveal anything but the blob that's posted alongside the rollup transaction for security reasons can effectively be reverse engineered, and so it doesn't really get you privacy today. And I do think it's possible, theoretically, to imagine a world where you can do a zk rollup, and Zach should weigh in on this, but I think it's theoretically, or I think it's practically quite complicated. And so my personal view is that scalability is one reason that people have cited that Ethereum has not been more widely adopted, but I would argue that the lack of privacy, the ability for people to not hide what they're doing potentially in financial transactions, is more what holds the space back. So to me, that has to be the starting point and the prerequisite for further adoption.
Actually, zk stands for these days for zipped by cryptography.
Well, we'll have to debate that on another panel.
Vitalik said so, so like no need to debate.
So yeah, I think I'm obviously more with Alex here, but to articulate my thoughts, what Alex and Brendan were saying about scaling privacy being roughly equivalent. At a very high level, yes, but I think that's like saying, I mean, yes, both cars and trains use internal combustion engines, but they serve very different purposes. Because blockchain is not just a computation environment, it's an execution environment, which defines an interplay between computation and state, and how the results of computation update persistent state. And if you want that to be privacy preserving, that requires radically different choices to be made when designing your network architecture and your systems architecture, which then leads to radically different choices in terms of the actual zero-knowledge cryptography technology stack that you select, because you have different resource priorities. So, yes, they are sort of the same, but we're rapidly seeing a large bifurcation in technology and architectures between scaling networks and privacy networks, or scalable privacy networks. And I think the further the space develops and the more that various networks specialize and refine, we're actually going to see more of a divergence between these protocols, and the more difficult it'll be to reconcile those technological divergences.
Yeah, I would maybe just clarify at this point that like in a zk rollup, you're using zk for both scalability and privacy. I would definitely not disagree that if you want a privacy-preserving smart contract execution environment, that does not look like the EVM. Like I don't think that anyone would disagree with that. Just
Cool. All right, so I think I'm gonna go into the EVM camp here, the zkEVM side, and really understand the unique designs that make you different, right, from each other. So, Polygon is using Vitalik's definition, a type 1, right, type 1 or 2, I would say. And then you guys, Alex, zk Sync side, it's more of a type 4. So can you explain, what are the trade-offs there? How did you come to that decisions? Start with Brendan, please.
Oh, with me? Yeah, so I think Vitalik's framework for classifying zkVMs, it just ranks types of zkVMs on how close they are to the EVM that's used on Ethereum. And so a type 1 would be a prover with the ability to prove blocks for existing chains. So you have to change nothing about the chain, and you can just generate proofs. A type 2 is offering an environment that's functionally identical for developers and for users, but on the back end, it uses different primitives for like the state tribe. And then as you progress further down the classification framework, I think it terminates at a zkVM where it's a different environment than Ethereum, but you can use a compiler to take some Solidity code, maybe with modifications, and run it in a type 4 zkVM.
So, like, I want to ask the audience a question. Have any of you run the virtual machine on your computer? Like, if you have a Mac, you run, like, I don't know, VirtualBox, and then you put some Windows programs there, right? Like, you can do that, and you can run any program in the exact same way. You just take the binary code, like for Microsoft Word, and you run it on the MacBook. Right? It will be in this window. It will have like the keyboard maybe will be like slightly whatever, but it will be slower. Or the other option is you can take this Microsoft Word code and you can compile it natively for your Mac, and then you can run it super smooth and fast, and maybe you can use some native features to Mac because your menu is going to be like more natively integrated and so on. So we thought if you're gonna be like, if the future is zk and you're gonna be running like native zk applications, they're gonna be much more performant, like massively outperform any emulated approaches, that it makes sense to start with this compiler approach. You can always add an emulator on top of that. Like for some specific cases, like maybe you want to run, like just port some special contracts and have the same address between different chains. You should be able to do that, but that's more an edge case. The default is you take the code and then you compile it. And this is why we chose the Type 4 approach to begin with the most efficient, most performant way. And if you check the fees, like right now, zkSync is by far lower cost than any other rollup, zk or non-zk, like by at least 50% margin.
Yeah. So, hold for applause.
Applause.
So one thing to point out though is that fees are massively determined by call data, which has nothing to do with the prover. I would just emphasize that if you look at proving cost, the proving cost is largely determined by the efficiency of the underlying proving system. And if you have more efficient proving systems, then regardless of whether or not you're doing a type 2 or a type 4 or a type 1, you will most likely have a lower proving cost. And so I think like our sort of thought process and design decision was based on the fact that if you give people an equivalent environment to Ethereum where all the developer tools just work, all the smart contract code just works, then the differences between, and I actually see Jordy in the audience. He's the man responsible for the first Type 2 zkVM. But it's a much better experience for users and developers because it's an identical experience to the L1.
Hey, that's not fair that you planted Jordy back there. I want you to know. But now, actually, I have a question on this. It's just a neutral question that I'm genuinely curious about. Is the goal, I guess, for both of your projects, is this characterization or this categorization, kind of implies some kind of progression? Do you all view is it the goal to get to the Type 1, and if so, why, and if not, why not?
No, so for us, we see different zkVMs and different zkVMs as satisfying different use cases. So if you have an existing Type 1 chain, an existing EVM chain, like Cello or BSC or Polygon POS is like a really good example, then you might not want to migrate that to a completely different zkVM execution environment. And so it's a nice thing to be able to take a Type 1 prover and instantly and seamlessly start generating proofs for that chain. If you're starting a new chain, you might prefer to make a different trade-off and use a Type 2 for lower proving cost. If you have a non-EVM application or non-EVM execution environment, you might choose to use a zkVM, and that's something that we're working on at Polygon as well. And so it's not like this progression where every chain terminates at Type 1. I think that there are trade-offs, and developers should be free to make those trade-offs.
I agree with Brandon. I agree with what Brandon said, and I want to highlight a specific use case for when Type 1 will be necessary, and this is why we're also going to bring it, and you guys are working on this. It's proving Ethereum Layer 1 blocks themselves. Because once you can prove Layer 1 blocks, then you can have your phone, like a wallet on your phone, verifying these proofs, and be sure that the Ethereum block that you're currently watching at is valid from Genesis, and all the chains that settled on this block are also valid, and you basically turn every single smartphone in the world into Ethereum full node. We're like bringing 1 billion full nodes to Ethereum is a massive decentralization boost, and this is what's going to happen.
Okay, let's move on to the VM side and see how that debate goes, right? So within the virtual, you're building your own virtual machines on both Aztec and Aleo, but you have very different approaches to that too. Aztec is an L2, and Aleo is its own L1. Explain your perspectives there.
You want to start, or you want me to?
Should I start?
Go ahead.
Well, for us, it was a bit of a no-brainer because of our, well, maybe just because of our backgrounds in the Ethereum ecosystem. But the way we see it, why is privacy useful? Privacy is only useful if you have value you want to hide, because nobody cares about how many magic beans you have, and so for us, we wanted to, from the kind of the commercial perspective, we wanted to build as close to the layer that had value on it. That was a source of liquidity, so that it's much easier for people to bridge into Aztec, use Aztec-based applications that we're tied into the Ethereum ecosystem. that can be happening through trustless bridges because our consensus is derived from Ethereum. So that was the commercial reason. But the other reason, which was really something which is a general philosophy that I try to apply with Aztec, is play to your strengths. Our strengths are cryptography engineering, and building products and systems using that cryptography. We are not consensus specialists. We don't want to build a consensus network. We felt like that would just be an anvil around our neck, and the maintenance overheads of maintaining that consensus network over time and making sure that it was upgraded to use the latest innovation so it didn't become uncompetitive would be an unsurmountable source of friction for us.
Yeah, so I actually think it was a no-brainer to not build on Ethereum for the following reason. So as an investor, I remember a time when everybody said no one wanted to learn Solidity. They're like, we need to have Viper or whatever. We need to we need to create languages that are close to things people already know because no one's going to want to learn a new language. And I remember a time when people said things about, I know we're at an ETH conference, but Solana, where people were like, it's another layer one. Who needs another layer one? No one's ever going to adopt that. And I think the reality is that it's still very early days, and I think what will ultimately drive people to adopt things is where they find real utility. And in my view, cryptocurrency, Web3 in general, has not really found a killer use case outside of speculative applications. There are some, I think, promising early areas, but I think for the most part, I think if you just look at on-chain activity, you can kind of convince yourself of this. Most of the use cases are speculative. And I think to get around that, we need to build an environment from the ground up that's purpose-built to enable privacy, but also enable programmability, but maintain that permissionlessness that makes Bitcoin and Ethereum special. And I think if you do all that, then I think you enable the potential for new use cases. Identity is one that I'm very passionate about. And I think those use cases themselves, I think, could grow to be billion or even trillion-dollar industries someday. And I think when you have from the perspective of a builder or an architect, I think when you add there's two ways to build. There's starting simple and then adding layers on top, like building a layer cake, which is I think how most people kind of think of Ethereum. You have layer one, layer two. I mean, Bitcoin's another example. You have Lightning Network and you've got other stuff, right? But I think the trade-off there is every layer that you add, there's now an interface between layers. And many times that interface you have to, that's added complexity that you have to deal with. Like the whole concept of a type 1 through type 4 zkEVM kind of gets at this. You're like, okay, well, I don't have, the bytecode is not quite compatible, so I just got to assume some different things about what hash function I'm putting in for this opcode. So there's just different assumptions that get made, and I think after a while, you get away from these core things that make a single monolithic blockchain unique compared to other types of software. So that's why we decided to build a fully integrated new layer one from the ground up to enable what I view are novel new applications that aren't possible anywhere else.
Could I just do a slight rebuttal, or maybe just focus on one point, which is that you mentioned that like the current applications on Ethereum on blockchains are speculative, and that and maybe I'm reading too much into this, but I might have detected a slight bit of disdain and contempt in your voice. And honestly, I used to feel that way, and I've changed my mind a lot, because you play the cards you have, not the cards you want to have. As in, there is $1 trillion in blockchain today, a lot of vibrant applications, and the current activity that has been created by blockchain has created the environment in which we can build and design these advanced protocols and systems. That, what you call speculation, is literally paying your salary, and it's paying your bills. And will likely, possibly, you're going to have to draw your first users from, because those are the current people that use Web3. So I guess I would say, don't piss on your users.
Also,
I can't rebut that.
Yeah. Sorry for being a bit harsh.
I also don't think it's like a unique thing about crypto that there would be a technological innovation that's accompanied by a financial innovation that drives speculation. If we look at like the development of railroads, those were enabled by the development of the Joint Stock Corporation. And if you read like what robber barons and like their offspring and their failed children were telling each other, it sounds like shitcoin trading. Like they say, I only pick the railroad stock that goes up, and like I just think it's like maybe a little bit short-sighted to view like what's happening at the very, very, very early stages of the development of this technological infrastructure as being sort of like dispositive or reflective of what's going to happen even in the near future.
That's very right, but I do just want to characterize. So I think that's all fair feedback. But I do think, well, so speculation can be a positive force, but it's not. I think we would all agree it's not the end goal, right? I think the end goal is we have real useful applications. We have railroads that actually carry freight and do things that everyone, including outside of this conference, sees utility in. So that's the only clarification I would make.
Okay. I promise I'm going to ask this hardball question to you first, Alex. So, Aleo has started 4 years ago. I guess this question goes to Zach to Aztec, right? 6 years ago. Why haven't you launched yet?
Sorry, I told her to ask this one. Look, these are very complex systems, and we only have one chance to get them right. And that's the nature of building blockchains. And I think, in particular, the choice, or the trade-off of the choice to build an end-to-end layer one that includes, a programmability layer, its own VM, a language, and a unique consensus algorithm that kind of accounts for all that and maintains the properties of privacy, permissionlessness, and programmability is hard. And there's a lot of ways it can fail. And because we only have one chance, and because everything is so self-contained, you kind of can't really launch until it's all together. So this is this is one explanation for why I think it's easier. I think it's frankly easier to launch a rollup, at least launch one. But I would argue that many rollups themselves are kind of incomplete. I think there's many people who kind of view, I think in the long term, this goal of having a decentralized sequencer. But from my view, I think, most of those conversations happen theoretically, and I think when you look at what a decentralized sequencer actually is, it is kind of the completed product, which looks a lot like a layer one blockchain.
So, your question, why haven't we shipped? We have shipped. That's very unfair. So in 2019, Aztec shipped Aztec 1, which was a confidential transaction system for Ethereum. In 2021, we shipped Aztec 2, which was the world's first zkZK rollup. And in 2022, we shipped Aztec Connect, which enabled Aztec 2 to interact interoperably with DeFi protocols in L1 and provide a privacy shield. So we have shipped. We've not shipped the grand design. And the reason for that is the technological hurdles we've had to overcome are fierce. And we've had this process over the last 6 years where basically we have taken the best technology available, which we've had to invent in-house because existing stuff just wasn't good enough. And we take that technology and we push it to its absolute leading edge and create a product that uses it and launches it. And it's only been in the start of 2023 when we had confidence that we had all the ingredients in place to build the full programmable private smart contract vision. And so that's when we made our move to actually, put our foot down and grind on building that. But I guess to really answer your question, shipping takes longer when you have extreme technological barriers in your way that you have to kind of pickaxe through Minecraft style through invention.
So I think I wanted to ask the rollups here, right? Since that was mentioned by Alex, the single sequencer, making it very decentralized, and do you think can make the chain less permissionless?
Less what?
Permissionless.
Of course. Like the centralized sequencer does make the chain less permissionless because the operator can censor it. So this is why we have been working for a long time on making a decentralized layer 2 consensus, and we want to switch to it as soon as we possibly can. Because the permissionlessness is the nature of blockchains. This is one of the most important, three top most important properties. But along with verifiability, or trustlessness in other words, and so the reason we even launched this centralized sequencer in the first place is because it does not compromise on trustlessness, right? So even though it's, the transactions in L2 are kind of permission from the sequencer, but the user is not permission to exit. They can always exit because they can prioritize transactions on layer 1 through priority queue. So if they don't if they are not welcome in the system, they can always leave. So this is already a very important piece of permissionlessness there. But of course, we have to transition, and we will, to decentralization very soon, this year.
Yeah, completely agree with Alex G. I'd also say that there's, I know, Alex, you've expressed maybe some frustration about the rollup roadmaps in the past. Yeah. And I think it's really, really important to emphasize what Alex just said, which is if you're launching an L1, decentralization is essential for security. Like, in order for your funds to be safe, it needs to be decentralized, and that is not the case on a rollup. Obviously, like, if we think about the like Maslow's hierarchy of chain needs, like security is kind of at the bottom, and then if we move up, like obviously we care about censorship resistance and permissionlessness, but those are like, you know, like we need to think about decentralization as being an instrumental goal to achieve those things, and like to really be specific about what the requirements are for L1 and L2 to be secure.
Okay. Let's move on to the next question. On the performance of the chain, right? So, you know, Aleo, to do proving, it takes 5 times the time as opposed to on zkSync, right? So is that because we use client-side proving, and why do we care about that?
Yeah, so I think, look, so the proof system that we have is a little less performant than some other choices, particularly those built on Plonky 2 or Stark-based systems that have more performant provers. But a principle that we really try and build for is this permissionless system where a client can be a prover, right? And this is very similar to how Zcash works. You know, Zcash, you can send a transaction to a Z address that's shielded effectively, right? And I think there is an interesting distinction happening right now in the space as to whether or not that's an acceptable trade-off. Whether or not it's okay for there to be only one prover or maybe a handful of proving marketplaces that have specialized hardware that can generate the proofs, or if you want to have the ability to generate a proof be more democratically available, you could say. So we very much feel, at least I personally see, that there's definitely going to be a world where proof generation is outsourced because people are not going to want to pay the costs associated with it either in time or money. But I do think it's critical, back to this core principle that I think Satoshi really first, you know, kind of enumerated around permissionlessness. And it really, if you look at if you read the Bitcoin white paper, a principle that's very clear is, and part of that is egalitarianism. Like there were big banks and there were not big banks, and Satoshi wanted to build a system to not recreate that. And I think very much, for me, a principle that motivates me is making sure everyone can be a prover, right? And there doesn't have to be a bottleneck. That comes at a cost of performance sometimes, right? If you're generating a proof on a client-side MacBook, it's not going to be as fast as you're running several, you know, servers in the cloud that can recurse and potentially aggregate a bunch of proofs together.
Can I quickly add a comment so I know where I'm going to go?
Sure.
I broadly agree, but I also think that it's very dangerous to in this space we have a lot of ideological overheads, I guess you would say, that companies have to operate on. We need to be, our decision making needs to be nominally democratic, maximally transparent, and things like egalitarianism, everyone can run a prover. Not everyone shares those views, and it's very easy for other people to kind of abuse those ideals by shipping faster, by ignoring them. So I think it's just something to be mindful of. Like on our end, for example, to be honest, it's a very nice to have if anybody can run a full like roll-up prover for Aztec. But you know, for V1, you know, that's not something we actually care about that much, because that can happen like 2-3 months later. You know, you get the core tech NAT down, maybe you need to run a really beefy compute to make a roll-up proof. But then, you know, in 6 months, the tech advances, you're good. What we care about the most is client-side proving, because our clients have secrets because it's privacy, which is the same as you, which has necessitated an enormous number of architecture and technological changes to our protocol to enable that rapid client-side proving, which also just means there's a happy accident. Proving a rollup of Aztec is a lot less computationally intensive than a zkEVM. Yeah.
Yeah, and I would just say, I think one thing that I think about here is I completely agree. Ideology is not the basis to make a decision around a product. I think what users will use it for is the basis to make a decision around a product. But I think for the certain use cases, and I mentioned identity a couple of times as one that I think is incredibly important. As you pointed out, like a user's identity information is secret. Like if you have to send that to a server to generate a proof for you, you've kind of created a more expensive version of OAuth, in my opinion. And what I think is really novel, if you want to implement a protocol like zkCreds, you do effectively have to rely on the client who has the secrets to be able to maintain that secrecy for that use case to work.
But sure. So it's really important to emphasize, though, that like a lot of those use cases are completely compatible with Ethereum. Like the only time that you truly cannot build a privacy-preserving use case on the EVM is, I believe when you have like you require anonymity for payments. And so like a lot of the identity use cases we're already seeing being deployed on Ethereum, on L2s, and you could say, yeah, it's like expensive to verify proofs, but with proof aggregation, we can amortize the cost of verification on the EVM.
That's really not the point, but we don't have enough time to I'd love to argue that. I'd love so much to spend a few minutes arguing that.
Oh man, we gotta have a sequel to this panel. All right.
Yeah, we have to. Yeah, let's end on a maybe merrier note here. What are you most excited about in the zk space in the next 12 months? Start with Alex.
The rise of zk networks with hyperchains, what we call hyperchains connected with hyperbridges, like many blockchains feeling like a one seamless big zk network.
Yeah, I think further developments in pushing proving systems further, pushing the technology further, and yeah, the Polygon Ag layer. So.
I'm most excited about applications and built by many of the developers that are in this audience on any of these protocols that solve a real-world problem that my grandmother finds utility in.
Yeah, I'm with Alex there. But things that particularly interest me are basically identity. If you can link identities to cryptocurrency accounts uniquely, then that enables blockchain to tap into the real world and affect real-world identities.
Cool. Great. Let's give it up to everybody on the stage. Thank you, Alex G, Brendan Farmer, Alex Pruden, and Zach Williamson. Thank you.